because of refraction? If anyone knows, just you guys can just answer it.
So refraction.
It is refraction, right? Now, correct. Because as the light is coming from the stars, okay, now it is there in the space, it is vacuum. But as it enters into the atmosphere of the Earth, so you know that there are different layers of the atmosphere of Earth, right? Troposphere, stratosphere, mesosphere, thermosphere, exosphere, ionosphere, different layers of atmosphere are there right now. And the layer of the atmosphere that is surrounding us is more denser as compared to the layers above it. Getting it what I'm trying to say? Because in the lower layer of the atmosphere, dust is there, different type of gases are there, so concentration is maximum. So what is happening basically, the light from the stars is coming from the space, and as it enters the atmosphere of the Earth, it bends. Meaning that suppose there is a star which is many light years away from us. When you talk about the distance of the stars, you don't measure it in terms of kilometer or meter or in miles. We measure it using a unit called as light years. All right now. So basically this is coming, and this is, let's say, our Earth, and this is the atmosphere of the Earth. Atmosphere is the thing, blanket of air, blanket of air that is surrounding the Earth. So as it enters the atmosphere of the Earth, it starts to bend like this. So that is why twinkling is happening. Getting it what I'm trying to say? Yeah.
I did not get it.
Not getting it. None of you got it.
I didn't got it. I don't
Okay,
know
okay.
about others.
Vaika or Chikrika, are you guys getting it or not?
No, sir.
Not
No,
getting it.
sir.
Okay, look, basically what happens, no? Okay, by the way, this is not part of the chapter, but still just let me clear this thing. Basically what happens when light is coming from any star or from the sun, right? So first phenomena that will be happening when light comes in contact with any object, it will bounce back into the same medium, that is reflection will happen. You look at your image in the plane mirror, it is because of reflection of the light rays that are falling onto you, and those light rays are then reflecting back from your body to the plane mirror. Meaning that there is a person standing here in front of the mirror. So someone, let's say there is a bulb here, so light from the bulb are falling onto the person and then reflecting from the body of the person onto this mirror, right? Now, so here reflection is happening, so due to reflection we are able to see our image in the plane mirror. So that is one thing. But what happens, suppose you are having a bucket of water, and let's say you have put a stick inside the water. Will you be seeing a straight image of the stick? No. You will see it will appear as if it has bent. Right now? Have you seen that? You put something into the water, it will appear as if it has bent.
Yes,
Or
sir.
if you can just take a glass of water, put something, a pencil or something into the water, it will appear as if it has bent. So this phenomena is called as refraction. Getting it now? This is simply called as refraction of light. So it is the air, and here it is water. Okay, now? So the case with the light is somewhat similar, that when it will be entering from the air into the water, it will start to bend. It will start to bend. Okay, now? So also, air is more denser or water is more denser? Answer this to me. Which one is having more density?
Right. So
Which?
air.
No,
Air.
no, no. Water is having more density, no? Density basically what means now? Density basically means the amount of substance that is packed into the given volume. How much of substance is there in a given volume, that is simply called as density. For example, you hold a cotton you hold a cotton ball in your hand, in another hand you hold a piece of rock of the same size. Which one will feel more heavier?
Around.
The rock, obviously. Although both of them are of this, let's say that you have taken both of them of the same size, but their mass will be different. Why is it so? Because in that same volume of the rock, more mass, more particles are packed. Is that clear? Getting it what I'm trying to say?
Yes, sir.
Yes, sir.
Hmm? Hmm.
Yes,
So
sir.
with that example, we can understand what density is basically. It is the amount of substance that is packed into the given volume. So obviously, now the light rays also are entering from a lighter density medium to the medium which is having more density, that is to water. So it will be bending. Now you tell me, out of vacuum and out of air, which one is having more density? Out of these
The
two, which one is?
So vacuum.
vacuum.
No. In vacuum, are there any air molecules? Are there any particles in the vacuum? I'm
No.
not talking
No.
about the vacuum cleaner machines. I'm talking about the vacuum in the space where there is no air, no particles, right? So
Then air.
obviously, then air, because air is having dust particles, different gases. So there are more particles in the air, hence it is more denser, right now. So same thing is happening. Now where this star is there, for example, let's suppose you are having the North Star. North Star, you guys know about North Star right now? That is directly above the North Pole of the Earth, which we call as North Star. So light is coming from the North Star, and as it enters the atmosphere of the Earth. So now understand, all the while it has been traveling in vacuum. Now, as it enters into the surface, into the atmosphere of the Earth, now it is coming in contact with air. And air being more denser than vacuum, it will bend the light. That's why you get to see the twinkling effect. That's why twinkling effect is observed. By the way, if you're not still not getting it, then just leave it. Just know that twinkling is because of refraction. You will be studying about it in detail in class 8. Light chapter is there in class 8. In that you will get to understand it more clearly. Okay, now. Okay, question number 3, Chakrika.
Yes, sir. A chemical change may involve, so D, any or all of the above.
Any or all of the above, right? Evolution of gas, change in temperature, uh, may involve change in temperature. Huh. Any or all of the above, correct. In fact, all of the above. Question number 4, yeah, Sundas.
Um, Sir, I think so. The C1 is correct.
C1 is correct. Okay. So its
Yeah.
change, its state is changed from liquid to semi-solid. That is correct. Color also changes, taste also changes. Right now. And the fourth one, the change cannot be reversed. That is also true now. Right now. So are there any options which from liquid to semi-solid? Yeah, it changes color. No, it changes color. No. 1, 3, and 4. Option number C, that is correct. Viga, question number 5.
So the first one,
Option number A or option you have
A.
to option number
No,
A, 1.
sir, I guess it's the second one.
Mhm. The second one,
Yeah,
2 and
option B.
3. Option B, to protect it from sun and then
Yeah.
make it look beautiful. No,
No, no, wait, wait.
prevent.
So one
Mhm.
second.
Meanwhile, Chakrika, you answer question number 6.
Yes, sir.
Sir, I
Sir, it
think,
is
option
iron.
Viga, which answer? Which
option
option?
A.
Option A, 1 and 2.
Yeah.
Correct. Prevent it from rusting, protect it from sun. Very good. That is option number A. Sundus, you look at question number 7. Viga, question number 8, and question number 9. Chakrika, you again have to do this one. Question number 6, what answer you are getting, Chakrika?
Yes, sir. Iron pillar near the Qutub Minar in Delhi is famous for the following facts. Which of these facts is responsible for its long stability? Sir D. It has not rested after such a long period of time.
Exactly. Right now. So iron pillar, the Qutub Minar in Delhi. Okay, no, it was built so many years ago and it has not rusted so far. So that is one of the property of it. Also, I did told you that it is made up of a special type of iron called as wrought iron. So the iron pillar, if you ever happen to visit Qutub Minar, nearby Qutub Minar, there's an iron pillar. Okay, no, and if you will find that it has been standing there for thousands of years and it has not rusted because 98% in it is an iron while the rest 2% is different other types of minerals. So different type of minerals, for example calcium, magnesium and other type of metals have formed a thin film over it, film, a thin layer over the iron, thereby protecting it from rust. Okay, no, okay, question number 7, Sundas.
Sir, iron.
Hmm, iron. Okay, no, okay. Also I did told one of the process via which galvanization is done. What is that process called as?
Sir, can you
Anyone?
repeat the question?
Galvanization is done to protect iron from rusting. What is the process required to do galvanization? Remember,
Like
we were
what is
using.
applied?
Huh?
What is
Rem-
applied?
no, no, not what is applied. Zinc is applied, and that is true. The question is, what is the is process called as? Where you are plating a layer of zinc over the iron. Electroplating. Remember? Yeah, Chakrika, remember about electroplating?
Yes,
We
sir.
just discussed it for 1 or 2 minutes. Okay, no. Anyways, that is not concerned with the chapter, but still no, okay. Using electroplating, it is done. Vaiga, question number 8.
Sir, option A.
Option number A. 1 minute. Paheli's mother made a concentrated sugar syrup by dissolving sugar in hot water. On cooling, crystals of sugar got separated. So this is indicating option number A, physical change that can be reversed. Yeah, that is true. Indeed, we studied that crystallization is an example of physical change. Can you guys answer some of the phenomena from daily life where you observe crystallization? Hmm. Also, simply answer what are some other crystals like
Salt.
salt is
Sugar.
also a crystal, correct? Yes.
So,
Sugar, it is there in this question.
copper sulfate.
Gemstones, crystals of copper sulfate also very good. All the different type of gemstones, all of them are crystals. Gemstones are precious stones. I'm talking about the precious stones. Okay, now ruby, emerald, diamond, all these are also crystals. Okay, now
Sir,
question number
snowflakes also.
which one?
Snowflakes.
Snowflakes are very good. Snowflakes is also an example of crystallization. Very good. Question number 9. Oh, who were required to answer this one? I think Chakrika, you were.
Sir, is it A? Heat may be given out but never absorbed.
Which of the following is incorrect for a chemical reaction? Heat may be given out but not never absorbed. That is correct. That is the option. Okay, no. So heat may be given out and heat may be absorbed also in a case of chemical reaction happening. All right now. Okay. So
Yes, sir.
what example do we have? For example, in order for a chemical reaction, heat may be given out. Burning of paper gives out heat. Right now, burning of paper gives out heat. And then, for example, in some reactions, heat will also be absorbed. What example can you guys think of a chemical change where heat is being absorbed? Think of an example. Yes.
So can you
Also,
repeat the question?
my question is that chemical changes have got several properties, like sound can be produced in a chemical change, color can change, uh, evolution of gas, formation of a precipitate, meaning that a solid residue can be formed. Yes.
Um, you said heat is absorbed, right?
Yeah, heat can be absorbed, heat can be released also.
Photosynthesis is also like an example.
Very good. Okay, now very good. Photosynthesis requires some amount. It absorbs heat energy from the sunlight also. Very good, Sandhya. Apart from absorbing light energy. Okay, now. So that is a
So
very good example.
neutralization.
Neutralization. Neutralization is also an example. So there option A is the correct one here. Okay, now. Okay, question number 10. The question is incomplete in this slide. I will be switching to the second slide. This question, Sundus, you are about to answer this one. Okay, now. Sundus, you answer question number 7, Sundus. Vaiga, you answer this question number 10. First, read the question. 2 drops of dilute sulfuric acid were added to 1 gram of copper sulfate powder. Okay.
Sir, actually, it's on this turn.
Sundus didn't know. Okay, then. Yeah, Sundus. 2 drops of dilute sulfuric acid. Dilute, you guys understand, a weak acid. Dilute sulfuric acid is made weaker. So you have taken H2SO4 and you are adding it to copper sulfate powder, right? And then uh, a small amount of hot water was added to dissolve it. Now on cooling, beautiful blue colored crystals got separated. Step 1 and step 2 are what? Hmm. It's a good question. Sundus, did you got the question first of all? You tell me.
Sir, I was writing the first question because like I couldn't like it was half right.
Okay, just take the screenshot now.
Okay, so you can move to the next slide.
Okay, okay. Let me assign other questions also. Chikrika, you do this one, and Vaika, you do this one. Okay,
There
no?
are 2 minutes.
Yeah.
So the answer is
Because
both.
Take your time, no issue.
just
Um,
Yeah, Sundas.
so the answer is C1.
so for the
Option number. Mhm.
so let's on this go on.
Hmm. So thereby, no, basically in first step, what we have done, we have dissolved the two. You have dissolved sulfuric acid and you have dissolved copper sulfate, right? And you will be obtaining a blue color solution. Okay, na? Like the one which we okay, hmm. Like the one which we discussed in the class, right? So you will be getting a blue color. And the second step is what you are adding some hot water into the solution of sulfuric acid and copper sulfate also to make it dissolve quicker. And on cooling, you will be obtaining crystals. So basically, crystallization is also being done here. So the question is step 1 and step 2 are as follows. If you were to look at the first one, in this case, what is happening? You are reacting to chemicals. So thereby, you will be obtaining a new substance in this case, right now. And in this case, what is happening? A chemical change is happening here. Getting it, Sundas?
Yes, sir.
So step number 1 is the chemical, while step number 2, that is crystallization, that is physical change. So option number B will be the correct one. Okay, now. Hmm. Question number 14. All three of you will be doing it together. Okay, now. So question number 15, question number 17. Sundar, I'm assigning this question to you. Yeah, Chakrika and Vaiga.
Yes, sir. Sir, I should say the 11th one, right?
Yeah, 11th one.
Yes, sir. State whether the following statements are true or false. Sir, A is true.
Hmm.
When a candle burns, both physical and chemical changes take place.
Correct. That is
And
true.
then B, anaerobic bacteria digest animal waste and produce biogas. So that is true.
Very good.
C, ships suffer a lot of damage through their paint, though they're painted.
Hmm. Although they are painted, but still they suffer a lot of damage.
So false.
No, it is actually true. It has to be true. See, they are painted. Okay, no, but painting is not going to make it rust free, because after some time, paint will go away. Paint will be eroded.
Oh, yes, sir, yes,
But
sir.
if it were to be galvanized, or basically if it were to be electroplated with some another metal which is less reactive, that will actually protect it. Okay, no?
Okay, sir.
So that
And
is
then
true.
D, yes, sir. And then D, stretching of rubber band is not a physical change. Sir, it's false. It is a physical
It's
change.
false. Because once you release it, it will restore to its original size. Okay.
Yes, sir.
Question number 12, Vaika. Question
Okay,
number
so
30.
melting of
Just 1 minute. Yeah, Vaika.
okay, so can I read?
Sure.
Okay. Melting of wax is a change where a solid changes to liquid state. Give one more such change which you observe in your surroundings. So ice melting into water.
Very good. So ice melting into water, that is also a very that is a simple example which we have, right? Okay, now. Okay, next question. Question number 13. Yeah, Chakrika.
So it's Sundas's turn.
Sundus, question number 17. You were required to answer this one.
So should I say 13?
It's a one-line question.
Okay, sir. What kind of change is shown by tearing of paper? Sir, it's a chemical change.
It's a
No,
chemical change.
so it's a physical change
How can it
actually.
be chemical change? It is a
It's a
physical
physical
change, that
change
is
actually.
correct.
I'm sorry, sir. Yes, sir.
No issues. But and then it is irreversible in nature, right?
Yes.
Okay, no? That is correct. Question number 14, we will do it together, but question number 17 first, let's do this one. Yeah, Sundus, question number 17. Write word equations for two chemical reactions. Okay, no? 1 minute. Write word equations for two chemical reactions with the help of materials given in the box. So following materials are given, and we have to write two equations. First of all, see what
So I have a
materials are
doubt.
given. Yeah.
So should we include all the examples, or is it okay if any one or two are left?
It's okay. It's okay. Not necessary to use all the words here. Okay, now.
Okay,
Mhm.
sir, I got one.
Mhm. Sandus, you getting it? Any one equation? Okay, Sundus, are you there in the class or not?
Yes, I'm there.
Uh-huh. Question number 17. Everyone try to solve question number 17. Okay, now? If you're getting an equation, please to let me know.
Sir, I got one.
That
But
is
I'm not sure if it's entirely correct.
okay. No issues. Just tell me.
Sir, iron plus air equals iron oxide.
Iron plus air. Okay, but you have to then include water in it also, no? Water also has to be included. Are you talking
Why?
about the rusting? Are you talking about the rusting
Yes,
of
sir,
the
yes,
iron?
sir.
So moisture also you have to include. Yes, Sundus.
Okay, sir.
It's a copper sulfate plus iron,
Hmm.
and then the iron sulfate plus
Plus
copper.
copper. Very
Copper.
good. Very good. Very good. Okay, no. Hmm. Okay.
So
There's
alright.
yeah. Vaigam.
So lime water plus carbon dioxide
Mm-hmm. Lime water plus carbon dioxide
gives us calcium carbonate.
gives us calcium carbonate. But I don't think a calcium carbonate is there in the question. Okay, so just let me write what equations we have got. The first 1 minute. The first equation which we had was this. We had iron, we had air, and we had water. So thereby we were getting rust right now. Or rust is basically nothing but iron oxide, Fe2O3 dot XH2O. Now what happens now? In rust, some amount of water is also found in rust because the reaction is happening between air, iron, and then water also. I have written XH2O. X means that it can vary, it can differ. Getting at what I'm trying to say? If there is much amount of water in the atmosphere, in the surrounding, so more amount of water will be found in the rust. Right now, so there could be one molecule, there could be two molecule, there could be three molecule, any molecule. It can differ. Getting it what I'm trying to say?
Yes, sir.
Okay, now.
Sir, I got another one.
Yeah. That one is
Copper sulfate plus iron gives us iron sulfate plus copper.
I think that one Sundus answered that one already.
Oh, okay, so sorry.
No issues. Copper sulfate plus iron, that is iron sulfate plus copper. So two equations which we are having right now. Okay. Now you guys do tell me, okay, there's a few more things in this. For example, vinegar is there and carbon dioxide is also there. Right now, vinegar is what? Acetic acid. Okay. Vinegar is basically acetic acid, carbon dioxide, and lime water. Lime. What is the formula of lime water? Had there been one more term in the question, that is calcium carbonate, then we would be having one more equation. Okay, no? So see,
So what is carbonate? Like what's the name?
CaCO3. CaCO3. Calcium carbonate. CBONate. Calcium carbonate. Okay, now. So if this was also included in the given in this box, we could have one more equation. The equation would have been follow like this. Calcium oxide. This is, what is another name for this? CaO. This is nothing but lime. Okay, no? This is nothing
What's
but
the formula?
lime.
I mean
What
baking powder.
what is the formula for baking powder? For baking powder, it is sodium bicarbonate, NaHCO3. That is the formula for it. Okay, now? Also look here, now this is lime water, but this is lime actually. So had there been lime and carbon instead of instead of lime water, if it was only lime and one more option calcium carbonate was there in the box, we could be having one more equation. Getting it, Chakrika, Sandus, and Vaika, what I'm trying to say? So that's why we have only two equations in that. Is that clear to
Okay.
everyone?
Yes, sir.
Hope it is clear. Okay, question number 14. In question number 14, look at option number A. We have to basically match it. So option number A, Sundus, you answer it to me. Large crystals.
So like
Hmm. Let me now assign
the
it. Sundus, you answer these two, Vaiga, and then Chakrika.
A to like the fourth one. Sugar candy.
Sugar candy, very good. Okay, depositing a layer of zinc on iron. What is the process called as?
Carbonization.
Galvanization, very good. Vaiga.
Okay, so sawing of milk is a physical change. I mean chemical change.
It's
Sorry.
chemical change. Next,
Carbon dioxide turns milk. I mean turns lime water milky.
turns lime water milky, very good. Okay,
Sir, iron oxide, rust.
that is rust, very good. Last,
Dissolving common salt in water is physical change.
physical change, very good. Okay, look at option number, question number 15. So, 1 minute. Question number A. Why can you answer this to me? Making sugar solution is a
Physical change.
physical change. Sundus, a physical change is generally
Reversible.
Reversible. Okay. Shakrika, grinding of wheat grain changes its size. So it is a grinding of wheat grain. Mhm.
Substance.
Change.
No,
It's talking
chemical
about
change.
change.
Sorry, chemical change.
How can it be a chemical change?
So because it changes its size, right?
So only physical property is changing now.
And it's also not reversible.
See, although it is not reversible, it is irreversible. But is it that the chemical composition of wheat has changed? Does it change? Taste different? If you
I
were
mean,
to
it doesn't.
if you were to chew the wheat grain, not when it has been grinded, and when you taste the flour, both of them taste the same, right? Because it retains the taste because chemical change has not happened. There is no chemical reaction happening. You guys
Okay,
getting
so
it or not? So thereby it is a physical change. Physical change, it said that generally it is reversible. So thereby it means that it is not absolute a statement. It can vary. We can have exceptions. Okay. Last question number D. Sundus, you answer this to me.
The iron benches kept in lawns and garden get arrested.
Hmm?
It is a chemical change because a
Correct.
new substance is formed.
Very good. Okay. No? So question number 16. Faiga, Sundus, Chakrika. Hmm. Beating of aluminium metal to make aluminium foil.
So physical change.
It's a physical change, correct. Digestion of food,
Chemical change.
chemical change. Cutting off a log of wood into pieces,
so physical change.
physical change, good. Last one, burning of crackers,
Chemical change.
Chemical
that's chemical
change.
change, correct. Question number 18.
Sorry, Vega.
Huh.
No,
Question
it's
number, anyone can answer it. Let me assign it to Sundus. You have answered this one. Okay. Sundus, you answer this one.
So which one?
Option number A, Sundus, you answer this one. Question number B, Vaiga, you this one. Okay, no. And this one, Chakrika, you explain to you answer it. So lime water is turning milky when carbon dioxide is passed into it. First of all, you guys tell Mickey, how do we obtain lime water? How lime water is formed? If I provide you with lime, will you be able to obtain lime water? Will you be able to make lime water?
Yes, so
By
squeezing it.
see this is one of the very common misconceptions I have seen in several batches. Lime is a different, lemon is different thing. Lime water is different thing. Lemon water is different thing. Here now it's not referring to lemon, guys. Lime is simply calcium oxide. Getting it now? Even when I was of your age and studying this chapter, I also got confused into this many times. Okay, now. Hmm. So this is calcium oxide
But I
also.
thought that lime is basically the one in green in color and the lemon is one in the yellow in color.
No, those are two different things basically. Okay. So lime is nothing but calcium oxide is called as lime. Okay. So how to obtain lime water? Simply add water to it. H2 is added into it. So thereby we obtain calcium hydroxide, that is the lime water. Okay, no? Anyways, now coming to the question, yes, on this. You pass carbon
So like
dioxide onto it.
what I have to do?
You just have to explain it. Why is it that it turns milky? Also, will
Mm,
it be a physical or chemical change? Answer that also.
like when the carbon dioxide, it is
Hmm.
like is um introduced in the lime water, it turns milky.
That is in the given in the question also. If you
And
guys recall, when the reaction was taking place between baking soda and vinegar, let me show that slide to you. When the reaction was happening between the two, carbon dioxide gas was evolved into that. Do you guys recall that?
Yes, sir.
Hope you guys were present in in that class, everyone. Just 1 minute. Let me show this slide to you guys. See, this is what I'm talking about. Reaction was taking place between vinegar and soda, and carbon dioxide gas was evolved. And in this test tube, you had the lime water. Now its color was changing to milky. The reason behind was that it was the formation of calcium carbonate. Getting it now? And calcium carbonate is white in color. Okay, no? Calcium carbonate is white in color. So it is because of the formation of calcium carbonate that the lime water turns milky. Is that clear?
Yes, sir.
Okay, no? Calcium carbonate is basically white in color. Okay. You might have seen it, like if you happen to visit village or some rural areas, there you will see that people would be painting their house using the calcium carbonate, which is white in color. Okay. Okay. Option number B. Question number B.
Sir,
White.
actually, I don't know the answer, so can you just explain it?
Okay. Just moments ago, just few seconds ago, I did told this thing. Like bubbles are produced when acetic acid is found in
Vinegar.
vinegar. So vinegar
And
is
sodium hydrogen
added to
carbonate is baking soda, sir.
its baking soda. So the slide that I showed you, it was in that it was given vinegar plus baking soda was forming bubbles, and those bubbles were
Oh,
that of carbon dioxide. Okay, now.
okay, sir.
So that is hope it is clear. Yeah, check Rika. Question number A of 19.
Yes, sir. Physical changes which are reversible.
Hmm.
So, melting of ice cube
Correct.
and freezing of water.
Freezing of water. Very good. Next one. Vaiga, sorry, Sundus, you answer the question number B, and Vaiga question number C.
like,
Physical changes which are
so,
not reversible.
um, the cutting of trees
Cutting of trees. Correct. Cutting of
and
woods, trees. Correct.
taking a bottle,
Breaking of hot.
bottle or
Okay, okay, basically glass bottle, glass. That is also correct. Good. Okay, Vaiga.
Okay, so chemical change like burning of matchstick or burning of
Mhm.
magnesium paper.
Very good, very good. Cooking of food, right now. Making curd.
Yes.
All these are the examples. Okay,
digesting food.
digestion of food. Very good. Right now, the metabolic activities happening in our body. Okay, there were a few more questions. You guys answer this to me. Give a change. Okay, now give a there's a chemical reaction happening. So give such an example of a chemical reaction in which color is changed. You observe that the color is changed.
So, rusting of iron.
Rusting of iron, very good. Okay, now can you give one more
So,
example?
burning of iron. I mean, burning of paper. I'm sorry, burning of
Hmm.
paper.
Burning of paper, that is also true. The one example which we studied in the class. Vaika,
So,
Sundus, Chakrika, one more. Yeah?
Sir,
copper
like
sulfate, like a
copper
diluted solution.
sulfate.
Hmm. Yeah, Vaika, go on. It was copper sulfate reaction with
Water.
iron.
I mean,
Iron,
yeah.
iron.
What, yeah.
Okay, now. So you had the copper sulfate solution. You added iron into it. So thereby the color of the iron changed to brownish color.
Yes,
Okay.
sir.
One more thing was observed. what happened? Okay, in this one, the copper sulfate is blue in color. Okay, now copper sulfate is blue in color. You dipped a piece of iron object into it, for example, an iron blade. So later
Yes,
on,
sir.
what happens? The color of the solution now changes to
Green.
greenish in color. Very good. So the color is changed into greenish, and one more thing has happened. The color of the blade has also changed to brownish, and this greenish. Can you who will answer this to me? Like this green solution is what? Is it copper sulfate or something else?
Sir, iron sulfate solution.
Very good. So that is iron sulfate. Okay, now, and this is copper sulfate. Okay. So hope it is clear. Okay. Give one more example where a gas will be evolved. Yes, Sandus, give an example of a chemical reaction where gas is evolved.
Vinegar. Like the
Yes.
carbon dioxide bubbles are there, right? The
Hmm.
baking soda plus vinegar.
Very good. Very good. Right now, we have several other examples also.
So
Like
does photosynthesis count for the
exactly.
I was
analysis?
about to say that.
Yes, obviously, it will be counting. Respiration will is also counted here. Okay,
Yes,
now
sir.
which gas is evolved in respiration?
So carbon dioxide.
Carbon dioxide gas is evolved. Very good. Okay, now. Okay. Give an example of a chemical reaction where sound is produced. Think of a chemical reaction where sound is produced.
Sir, vinegar plus baking soda, we hear a hissing sound.
Okay, how the coming of the bubbles will produce
So
a hissing sound. Mhm.
burning.
Burning,
Yes, sir. Like burning
burning,
of gasoline.
burning of gasoline. Most of the times it is silent. Okay, now
Sir,
most of the time,
firecrackers.
firecrackers. Exactly, firecrackers. Okay, now burning of crackers, burning of firecrackers. So that is a very good example. Okay, now
So lighting of a matchstick.
lighting of a matchstick. Very good. Okay, now so these are some of the examples. Okay, so we have practiced sufficient amount of question from the chapter. If you guys have any doubts, any questions from the chapter, please do let me know. Yes, any question from the
No,
chapter?
No, sir.
Okay, okay then. So now you guys tell me that which chapter we should be revising next, or should we just move in the sequence manner, or like we should be focusing on those chapters which are going to be part of your upcoming exam first. I think
So
which
by the way, talking about portions, I've sent you the portion.
okay, the portion in which you were absent, no? Mm-hmm.
No, sir, the portion which are coming from for my exams.
Yeah, exactly,
Like,
exactly. I'm talking about that portion which is going to be in your exam and in Viga's exam also. Okay, now.
no, sir, before you asked me to send, right? So I'm telling that.
Okay. Just let me have a quick look at it as well. You did send the syllabus to me now. Just 1 minute. So these are the chapters which are going to come, Chakrika, right?
Yes, sir.
Mm-hmm. Transportation in animals and plants. So we have done that, I think. Yeah. Right.
Yes, sir. Yes, sir.
Motion and time. Motion and time. That chapter we have. Were you present? You were not present, I think. Or were you present?
No, I think I was present, sir.
You were
We were
present.
learning about the oscillation of the pendulum and all that.
Yeah,
Circular
exactly.
motion, actually.
Okay,
Yes,
okay.
sir.
Good. Vaiga, have you also shared your syllabus with me?
Sir, I didn't get mine.
Not yet.
No,
Okay,
sir.
okay. Okay, so you guys, by the way, we will be revising all the chapters, okay, now? Even if few chapters are not going
Okay,
to be in exam, we are going to revise everything, okay, now? Because there are so many fundamental things about the information of which you guys need to retain, okay? So motion and time, you guys tell me, we were studying different things in that chapter, okay? So do tell me, I'm giving you some examples. For example, in order to measure time, can you use a pendulum to measure time? can you use the shadow of an object during the day for the measurement of time?
Yes.
Earlier we had example of sundials, if you guys know about
Yes, sir.
sundials,
Yes, sir.
right now. So by looking at the shadow of an object during the day, you can tell the time. Earlier it
Yes,
was
sir.
used. So sundial would be a structure like this, I believe. Okay, now. So wherever the shadow will be falling now, right now, that will be telling you the time throughout the day. Suppose the shadow of the sundial is falling in this here. So that will be giving you a specific time during the day. So yeah, that can be used. Suppose like blinking of an eye. Can that be a tool to measure time?
No, sir.
No,
No,
sir.
right? Because the rate of blinking will vary from person to person.
So what pendulum we can use, right?
Pendulum can also be used.
Yes.
Okay, no. Also, motion is of different types. Different types of motions are there.
Yes, sir.
Can you guys tell me what are the different type of motions?
So uniform motion and non-uniform motion.
So
Okay, that is
rectilinear
one
motion,
category.
circular motion.
Hmm. Rectilinear motion, circular motion.
So slow and fast motion.
So that is basically referred to the speed. Okay, now.
Yes, sir.
Mhm. And then we had one more, rotatory motion, right?
Oh, yes,
Rotatory
sir.
motion is there. Periodic
Yes,
motion
sir.
is there. Okay. So you guys answer some of the
Sir, I have a
examples of.
doubt.
Yeah, Chukrika.
So they say it is commonly known that like basically
Mhm.
motion and time are relative. Why?
Motion and time are relative.
Relative.
See, basically the concept is such now. 1 minute. I'm erasing this slide. Okay, now. See how motion and time are relative to each other. See, for example, now suppose there is a pole. This is the road, and there's a car here. Hmm. Now, what happens? There's a person standing here who is sitting on a chair, or who is standing basically here, and he looks at the car. Okay, and right now in the clock, let's say it is 5 a.m. Okay, now. So now he sees that this car is moving, and it moves ahead of the pole. And in order to move ahead of the pole, let's say it took 1 minute. It took 1 minute. So now when this guy looks at the clock, by then it would be 5 hours 1 minute. Right now, so far clear. So basically,
Yes, sir.
motion here is described as the change in the position of an object, okay, now, with respect to time. Because if the position is changing here, it must be taking some time. Getting what I'm trying to say?
Yes, sir. I get it.
Okay, now. So as the time changes, it will be as a position of the body is changing, it will be taking some time. But what if the car is at rest? What if it is at rest and it is not moving? So in that case, the time will keep on increasing,
So basically,
but
it's
the
a
body will
non-uniform
not be.
motion, right?
It's the moment for.
It's like basically a non-uniform motion, right?
That's a different thing. That's a different discussion. Right now, talking about how time and motion are relative. Okay, now uniform motion
Okay,
and
sir.
non-uniform motion are a concept where we study in uniform motion when equal distances are traveled in equal interval of time. So that is uniform motion. When unequal distances are traveled in equal interval of time, that is non-uniform motion. Okay, now. So now look
Okay,
at
sir.
the second situation where now the car is at rest and the time will not stop. No, time will keep on passing. So thereby, whenever we define motion, we consider time also. So motion is defined as the state of change of position of an object with respect to time. Is that clear? So that is one thing. Also, motion is relative in nature. For example, what do I mean to say that? For example, there are two passengers sitting in this car. Let's say there are two passengers inside the car. Now, these two passengers, in respect to each other, are they at motion or moving? Inside the car, there are two passengers. They are sitting on the seat. Inside the car, with respect to each other, are they moving or are they at rest?
Yes.
At rest right now. Like all the students sitting in the school bus, the bus is moving towards the school. Although the bus is in motion, but the students sitting inside the bus with respect to each other, when they look at each other, are they changing their seat? Are they changing their position inside the bus?
No.
No. Why are you getting it, Chakrika? Sundus?
Yes,
Hello.
sir. I'm getting.
Okay.
Yes.
Okay, no. So that is the thing here. So also why I have drawn a pole here? Because with respect to this pole, which is a stationary object, its position will not be changing. It is fixed into the ground, right now. So when further we add one more point about motion, motion is defined as the state of change of a state. It is defined as the change in the position of an object with respect to time and with a reference point also. Reference point will basically be a stationary object, or if a person that is standing here and he is not running, not moving here and there, so these are the reference point, a body that is stationary right now. So the pole has been there, but the car has moved from here to here. Hope you guys are able to understand this.
Yes.
Okay, no?
Yes, sir.
Okay. Give some example of rotatory motion.
So Earth,
Very good. Rotation or revolution? Revolution, right? Okay. One
yes,
more
sir.
example.
Uh, the merry-go-round,
Hmm.
Is it the Ferris wheel?
the hands of a clock.
So
Ferris
rotating
wheel,
fan.
rotating fan. Huh? So out of the options you guys have given, merry-go-round is correct. Okay. Um, the rotating fan, not the hands of the fan, just the rotating fan. Okay, now
Sir,
Yes,
hands
sir.
of the
Soccer.
clock.
talking about this,
Soccer.
this not the hands of the fan. Let me explain it in a minute. Yeah, Sundus.
The soccer ball.
Soccer ball. Like if it is rotating at one place and not moving further, so that will be considered as an example. Okay, no?
Sir,
Spinning.
So you
hands
can
of a
just
clock.
see, no, not hands of a clock. Let me explain that. The spinning of a soccer ball. See, the problem with the Ferris wheel is now, see, first of all, let me explain the rotatory motion. One more common example we have spinning top. See, in the case of a rotatory motion, consider the example of the rotation of the earth. So earth has its pole now. There are poles of the earth, north pole and the south pole, right now. So there is a axis which is passing by the north and the south pole. This is called the axis of earth. Axis is nothing but a line, a imaginary line that is passing through the north and the south pole of the earth, and it is slight bit tilted. Also look at the spinning top. When we look at the spinning top, so there is a nail.
Sir, I have a doubt.
Just let me finish this one, Chakriya.
Okay,
Just wait
sir.
for one
Okay,
minute.
sir. Okay, sir.
When we look at the spinning top, no, there is a nail that is inserted in the middle of the spinning top, right now, guys? Getting it? What I'm trying to say. So all I'm trying to say here is that in the case of a rotatory motion, there will be an axis around which the body will be moving. There is an axis around which the body will be moving. Is that clear to everyone? There will be an axis around which the body will be moving. Okay, now? Also look at the fan. This is an axis around which the fan is rotating. Right now? Is the point clear? You can look at the
Yes, sir.
merry-go-round also. There is a central rod in the merry-go-round around which ball bearings are also there, and around which it is rotating. So these are spinning top also. You can imagine an imaginary line in the middle of the soccer ball around which it is rotating. So these are the examples of rotatory motion. I hope you got it. And why the Ferris wheel is not an example of it? The reason to it is that if you were to look at the Ferris wheel, so here all of them are moving around a central point. So that is an example of a circular motion. If a body is moving around a point, okay, no, so that is called as a circular motion. And you look at the distance of all the seats from this point, it will be equal. Okay, no? Then you have the example of the rotate blades of the fan. They are also moving in a circular manner around the point, around the central point of this fan. Yeah, Chakrika.
Yes, sir. Sir, can you explain why the hands of a clock is not a rotatory motion?
See, because the thing is that the hands of the clock are moving in this manner, and they are moving around the center of the fan. Let's consider just 1 minute. Let's consider this is the center of the fan, around which the blades, the hands of the fan are rotating. So the definition of the circular motion is
I
that
said the hands of a clock.
hands of a clock, that can also be understood in the
I've
same
been
manner.
telling that since 5 minutes.
Okay, okay, no issue, no issue. I did it. I just thought you were talking about this one. So look at the hands of the clock. All of them are joined to the center point. All of them are joined to the center, yeah, right now, and they are moving in this manner, right now, in the clockwise manner. So they are also moving around a point. They are also moving around a central point. So that is why there is this is an example of a circular motion. You tie a piece of a stone to thread, you roll it like this, you whirl it like this. So that is also an example of a circular motion. Getting it? The revolution of the earth around the sun, that is also an example of a circular motion. You guys getting it or not? So whenever we talk about rotating motion, you have to keep in mind there has to be a central axis around which the motion will be happening. Okay, no? So this chapter we will be taking up in the next class. We will discuss few more things in the chapter, and we'll be basically doing questions in this chapter in the next class. Okay, no?
Okay, sir.